Okay. So we're going to be working with both two-column proofs and flow proofs today. Let's do flow proof for this one. How do I start? With the givens. So for a flow proof, I just make a little box and I put my given in it. TH is congruent to MH. And then underneath that box, I write the justification for it, or the reason, which I'll say given. And every time I build a congruent statement, something that's important for me, that has an impact on my proof, I'm going to come up here and make a notation in the picture. I'm going to make those little hash marks to show that that's what I'm doing. I've got another given, so I may as well throw that one in. I'm going to do it over here. Also given. THA. So this one here is congruent to MHA. Now you remember that I like to think about going to the end of the maze on the Denny's menus, right? Where are we trying to get to? What's our final step? My flow is going downhill here. So I know down here somewhere, I'm going to say A is the midpoint of TM. Any ideas what my reason for that's going to be? Parker, what do you think? Yeah. What does a midpoint mean? It means it slices it in half. So if just prior to this, we were able to say that MA is congruent to TA, wouldn't that then let us lead to this fact, calling it the midpoint, because that's the definition of midpoint? Okay, but why is MA congruent to TA?
Because it's the bias, I forget what it's called, but it's the line that goes right down the middle and splits.
Yeah, that's the midpoint, right?
Yeah.
So what we're saying is that because these things have been split in half, we can call this the midpoint. So it's fairly certain we're not going to have that knowledge about them being a midpoint to create that segment to then say it's a midpoint. So we have to come up with this a different way. The last two problems you did in last night's homework, 11 and 12. Yeah, if we say that triangles are congruent first, then we can say that the corresponding parts are congruent. So in other words, just before this, we have to be able to say that triangle MAH is congruent to triangle TAH. And then once we've been able to say that, we can move on to say these parts are congruent because the corresponding parts of the congruent triangles are congruent, CPCTC. And so now I've reverse engineered my way back up to just be proving triangles are congruent. Well, we've got one fact already. We've got two facts already. So what's my third fact? Yeah, AH is congruent to AH. Why do we get to say that? Well, we don't know it's the midpoint yet, do we? Yeah, it's a reflexive property of congruence. In other words, AH is the same in both triangles. So we can say it's the same. And that lets us say that these triangles are going to be congruent from these three facts. And when I draw in my notations from this reflexive, this gives me the visual. What's my reason for these triangles being congruent? Say again? SAS, right? SAS. Remember that those terms, SAS, SSS, ASA, AAS, and RHL, are the only ways we're proving triangles congruent at this point. How do you feel about that? 5, that's intelligible. And I think I could put that one together myself. 3, I followed your logic. I don't know if I could have led the tribe through this, but I understood it. 1, it's cool the way you're both math and magic. Okay. Let's keep going. We're going to go to 14, and this time we're going to do a 2-column proof. Throughout tonight's homework, doing 13 through 24, you're going to alternate between doing a 2-column proof, QED, and doing a flow proof. This is a flow proof. Now we're doing a 2-column proof. So let's draw out the picture for number 14. Is it? What is it that jumped out at you, Harris, to make you say that's a tough one?
There's three triangles.
Yeah. Visual chaos or noise that's messing with you. So I'm going to do these over here because we're going to make a 2-column over here. Again, this time we're doing a 2-column proof. So the left column is our statements. The right column is our reasons. And where do we start?
Givens.
Givens. Number 1, AB is congruent to AC. And my reason for number 1 is given. And what should I do since I've just written a congruence statement? Mark it. Over here, make AB and AC have the same number of hash marks. I'll choose 1. Now let's do a second given because we're given 2. BD is congruent to CD. And again, I've written something important, so I'm going to add it to my picture. BD is congruent to CD. Now, some of you may have a sense of where we're going. Some of you might have no idea. But we know what our final destination is, right?
Yes.
Angle BAD is going to be congruent to angle CAD. Any thoughts as to how we could arrive at that conclusion? Lila?
Well,
Okay. So you're saying we're going to get AD is congruent to DA because of reflexive property. And when I add that fact in here, you see that we've got 2 triangles that are completely done up. Right? They are set up for us to demonstrate that they're congruent. Doesn't matter. I would tend to do that in this case because they're aligned the same way, but it really doesn't matter. They're the same object. So now that we've proven these 3 things and it's given us these 3 side pairs, what are we going to say for step 4?
ABD is ABC.
I wrote exactly what you said, and we're missing one piece. The triangles. Remember that 3 letters could be an angle, like we have here, or a plane, or a triangle. We have to be really clear that here we're saying that the triangles are congruent. And what's our justification for that? Why can we say these 2 triangles are congruent? Good. SSS. And once we know the 2 triangles are congruent, we can just jump to this last fact, right? If the triangles are congruent, then all corresponding parts are also congruent. BAD and CAD are just corresponding parts of these now congruent triangles. CP, CTC. means corresponding parts of congruent triangles are congruent. Yeah. Say again. Is that right? A, B, good point. Guys, Jean is right. Did you catch the triangle mistake I made here? A, B, D should be congruent to what triangle? Almost. We have to match up the parts. ACD. Thank you. Good catch. That's very important. All right, let's set up 15, which will again be a flow proof. Yes. Okay, how do we start? Yep. Is this going to be a case of CPCTC or is this just going to be a straightforward one? Well, we're ending at the triangles are congruent, not the parts, right? So I think this one's going to just be that step. We're not going to have to go through CPCTC.
Do you know the difference between ones like statement and reasons and this?
This is called a flow proof, where you set up boxes with arrows, whereas a 2-column proof is the statements and reasons, and they're just two different ways of doing the same thing. And right now I'm giving you experience with both of them, and eventually you'll get to choose which one you like better. I haven't written the third given down yet, and I'm doing that purposefully. What information is this giving us? How am I going to use that? Good. We can't call it angle A though, can we? What do we call it? Angle BAD. That's this one. And this one gives us angle CDA, are right angles. In other words, both of these things feed into our combining the information into this one statement. And what's my reason here? Why do I know that this must be a right angle and so must this? Close. What does this symbol mean? Okay, and what does that word mean?
2 right angles and it's the
Yep. Not necessarily bisector. This doesn't mean perpendicular bisector, it just means perpendicular. And so the definition of perpendicular is that it makes right angles. Okay, now let's come back. And Jonna was suggesting we're missing one of our givens. So let's put that in now. AC is equal to BD. And when we write it here, we're going to add it up here. This is a little hard to see. Where am I going to put my hash marks to show that AC and BD are the same? It's right. It's going to look weird. In fact, do you see the triangles I'm trying to prove here? That's one of my triangles. And that's my other triangle. These triangles are overlapping. So one strategy that helps us do these more challenging problems like this would be to separate them. Give ourselves a slightly augmented drawing, separating out the parts. So A, B, D, and A, D, C. And now when we put in the right angles, and we put in this AC and BD thing, that's easier to see. Well, we're pretty sure this piece is going to contribute to the triangle congruence. Is that a side or an angle? That's a side. So what are we going to get to here? Can you predict which rule we're going to use, which theorem? RHL. How'd you know that? Because we got right angle. We could turn those into congruence, but this gives us our R, and this gives us our H, right? Right angles, hypotenuse. So we're on our way to get RHL. All we need is the L. Look at that. AD and AD are the same sides. So we can say that AD is congruent to AD by what reasoning? Good. And this probably would have been a better case to AD and DA, right? Because of the way they're oriented, but I just did it this way. And that gives us our third fact, which does do our leg, giving us RHL. And that's all we needed this time, so QED. How's this helping your confidence? 5, I'm feeling much more confident about these. They're not as hard as I thought. 3, I'm getting a little improvement, but it's still pretty slow going. 1, this is just making me feel bad because I'm not understanding this stuff. Okay, hands down. Let's go on to 16. Yeah. All right, 16. Draw it up, set it up, please.
That's great.
Okay, and here we're trying to prove Tn is congruent to Tk. Oh, Ik. Okay, take a moment, please, to look at this and see if you can put together a strategy. How would you approach this?
Do you have to work with me on this one?
Let's do this one as a 2-column, right?
Oh, goodness me.
Mr. Erlin,
Yeah.
how do you know which problem to do a column and like the other method?
And a flow proof?
Yeah.
That's a bigger question when you get further along, like how you can pick. But for now, you get to pick. You're just doing half of each.
So it's either works.
Yeah. So at this point, I'm just saying, let's do odds as flow proofs and evens as 2 columns. Anyone else feeling confused by the picture? What's our strategy to clean it up a little bit?
Oh, split the two triangles in front.
Good. So which are the 2 triangles?
T and
Good. Good. That one, right? Yeah. And I think it does help to separate them because then you can see better. Thank you. So I've put my givens in place, and now I'm looking for this eventual destination. Do we know why we're going to hit this? You're right, it can't be angle, 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 but this is not a given fact I'm working towards. I like what you're thinking, Harris. You're saying, I've already got 2 angles, so we're going to have to put some sides in here. But this is my prove here. I know this is the last step. Do I know what my reason is going to be? There's a very good chance that's going to be right. And if that's my reason, what has to be the step just prior to that?
T N is the angle. No, triangle.
Good. I and K, right? We have to keep it oriented. All right. And if we're going to say that triangles are congruent, it's going to be either angle, angle, side, or angle, side, angle, right? Because we've already got 2 angles. We know it's going to have an angle and another angle. What's the other piece of information hidden inside here that we can find? A side, okay. Do you think it's TK and IN? KN and KN again. And again, that reflexive saves us. And that leads us into this one directly. So what do I call it? AAS or ASA? Yep. AAS. AAS. You guys want to do them, or you want me to do one more with you? One more? You can tune me out. Do what? Do it and then go over them. I'm going to do one more just because I like this one. And we're doing a flow proof this time, right? Yep. Sure. Harris, would you be Johnny Appleseed? Let's get. Yeah.
What is the letter for the subject given?
E is the midpoint of AC. Angle 2. All right, how do we start? Given.
I gave away all the sheets.
Perfect. All right, so I put in my first given. E is the midpoint of AC. Does that give me anything? I don't get to like mark anything right away, do I? But what does it mean that it's the midpoint? Oh, I can, because a midpoint means it splits them in half. So we have to say that. So we'll say AE is congruent to CE because that's the definition of a midpoint. Right? You're right. That's information we had, but we didn't see it until we say it. Okay, then we had a given of angle 1 is congruent to angle 2. Once I write it, I can make the little notations for it. You mean parallel? Sort of. So there is a way to do this. What John is recognizing is that 2 and 1 are what kind of angles? Good. They're alternate interior. AC is the transversal. So we could say that BC is parallel to AD, because if alternate interiors are congruent, then the lines must be parallel. And then we could say, well, 3 and 4 are also alternate interior angles. So if we've got the parallel lines, we call BD a transversal, we could say they're congruent. But that's a lot of steps. Can we do this faster? Do it with triangles. Do you see the 2 triangles we're dealing with? That triangle's already got 2 pieces of information, doesn't it? I've got an angle and I've got a side. What do I need? What about this?
Oh, yeah.
Vertical angles. Well, we don't, but I know that I've already got 1, I've already got this side, and I'm looking for 3. So if I tie it together to the other triangle that's got 4 in it, that's going to give me that CP-CTC relationship I want. So angle BEC and angle DEA are vertical angles. Why do I call them that? Because that's their name, definition. And then I can say, because of that, angle BEC is congruent to angle DEA. What's my reason for that? Yep, if vertical, then congruent. And now with these 3 facts, do I have enough to prove my triangles are congruent? I do. So I'll say triangle. What should I call it? Maybe AED. CEB. And why are they congruent? Which 3-letter combo will I use? Good. ASA. And having proven that the triangles are congruent, I can take that 1 extra step to say CP-CTC to say that any corresponding parts are congruent. Which is what I was going for, QED. Okay, please finish up this document. You're going to be doing 18, 19, 20, 21, 22, 23, and 24. Again, alternate 2-column proofs and flow proofs. Think carefully about making logical steps as you go. You got the rest of the period to work on.